fourth point on my demand curve. At that price of 7 with quantity demanded of 12, my total revenue is, let's say 84. It's a good number. We all remember our 12s times table. If I kept going, presumably I'm going to wind up with a nice downward sloping demand curve that connects all those dots. If you draw a line and all your dots aren't on it, what should you do? Make your dots bigger. That's right. All right, marginal revenue. Marginal revenue, remember, is the change in total revenue divided by the change in quantity. Notice our quantity is not jumping by 1, but our quantity is jumping by 4. So here, when we're going between a price of 10 and a price of 9, the change in total revenue is 36. The change in quantity is 4. So my marginal revenue, 36 over 4, or 9. Let me draw that dot in. I'll change color because it's fun to do so. So, that's the marginal revenue that applies over that whole range from 0 to 4 of quantity. Over this. So I'm going to stick it in the middle. So here's 9, and 9 is stick it in the middle right between 0 and 4. That's the marginal revenue that is acquired from each of those additional units between 0 and 4. When we go from a price of 9 to a price of 8, the change in total revenue is 64 minus 36, which is 28. The change in quantity is 8 minus 4, which is, again, 4. And so the marginal revenue there is 7. So I'm going to find 7 over here on my vertical axis. And that's the marginal revenue when I'm going between 4 and 8. So let me just stick it someplace here in the middle, between 4 and 8. Nice big dot. And then one more time. When the price goes from 8 to 7, the change in total revenue is 20. The change in quantity, again, is 4. And so the marginal revenue there is $5 additional revenue for each of those additional 4 units. Find 5 over here on my vertical axis. And this is applying to that move from 8 to 12. So I'm going to go right in the middle between those two. Draw a nice big dot. I could keep going. Not going to, but I could. And I would, okay, big dots so that all my points are on my line. There, bigger dots. If I connect those, I've got my marginal revenue curve. With perfect competition, the marginal revenue curve was horizontal because the marginal revenue never changed. If a perfectly competitive firm wanted to sell more output, they would sell it at the market price. And so the additional revenue that they would get from selling one additional unit was always just the price, which is why the marginal revenue curve in perfect competition was horizontal at the market price. But a monopolist is facing the entire market demand curve. The monopolist isn't facing just a little bitty chunk of that demand curve, which is what our perfect competition firm was doing. The monopolist is facing that entire downward sloping demand curve. And so if the monopolist wants to sell additional quantity, the only way for the monopolist to sell additional quantity is to lower the price. If this is what we call a single price monopolist, which means they're going to charge everybody the same price. They're not charging you $10 and you $9 and you $8 and you $7. They're charging everybody the same price. Then with this single price monopolist, if they want to increase the quantity sold, they have to lower the price, not just on that last unit, but on all of the units they're selling. And so we get that price effect and quantity effect. We get that on the, let me do some numbers here. Look at this pair here. As they lower the price from $8 to $7, the price effect is that there is a lower amount, $7, that's collected on each unit that's sold. And so they're lowering their total revenue because they're lowering their price. That's the price effect. At the same time, however, the quantity is going up. And so as they increase the quantity sold, there's a greater quantity being sold. This is what they call the quantity effect. There's a greater quantity being sold, and that greater quantity being sold, that's going to increase their revenue. So you get a price effect, which in this case going from the third to the fourth row. The price effect here is negative because the price is going down, so that's going to lower their revenue on what they sell. But at the same time, the quantity effect is positive because they're selling more stuff. You look at which one outweighs what, whether the price effect is bigger or smaller than the quantity effect to figure out whether marginal revenue goes up or down. In this case, revenue went up, which means that the gain from selling more is smaller than the loss from selling everything at a lower price. So the marginal revenue doesn't equal the price because the price has to get lowered in order to increase the quantity that they're selling. Let's look at a marginal revenue curve in general. I'm going to put things, again, measured in dollars on the vertical axis. We're going to have the demand curve. We're going to have marginal revenue. There's so much stuff I'm measuring on the vertical axis. I'm just going to put dollars because it's all measured in dollars. And the quantity here along the horizontal axis. Draw yourself a downward sloping, make it a straight line for this purpose, downward sloping demand curve. And in general, for a monopolist, which faces that entire downward sloping demand curve, the marginal revenue curve starts at the same point on the axis and then splits the difference between the vertical axis and the demand curve. So just go over here, choose any place along your vertical axis, dash over, find a spot that's sort of halfway in between the vertical axis and the demand curve, make it a big dot if you're not quite right. 2 points make a line. There's your marginal revenue curve. So the marginal revenue curve splits the difference between the vertical axis and the demand curve. It has twice the slope. Notice, back to the question about elasticity, notice that the marginal revenue curve is going to drop down and cut through that horizontal axis. That is to say, marginal revenue at some point is going to be negative. Values above the axis are positive, values below the axis are negative. Well, let's find that quantity where your marginal revenue curve crossed your horizontal axis, and let's label it quantity Q1. And let's dash up. I'm just going to keep dashing up, so I've got Q1 marked there all the way up. For quantities that are less than Q1, so for quantities over here on the left, for these quantities, when the price was decreased, it led to such a big increase in quantity demanded that total revenue rose. We know that because the marginal revenue is greater than 0. I'm running out of space. Well, if an increase in price, excuse me, wrong, back up. If a decrease in price, my bad, if a decrease in price leads to an increase in total revenue, is that elastic demand or inelastic demand? I got lots of different answers. A decrease in price led to such a big increase in quantity. There you go. Just got to put the emphasis on the right word. So that part of your demand curve that's to the left of this quantity Q1 is where demand is relatively elastic. If we look at the quantities to the right of Q1, then for those quantities, as the price is lowered, up here on the demand curve, as the price is lowered, yeah, there's still an increase in quantity demanded, but the increase in quantity is so small that the marginal revenue is negative, which means the total revenue is falling. Well, if when price goes down, the increase in quantity demand is really small, are we in the elastic or the inelastic range of the demand curve? Inelastic. So a drop in price with a little bitty change in quantity is the inelastic part of the demand curve, which gets back to the question that was asked a few minutes ago. A monopolist who wants to maximize profit is going to choose to produce the quantity where marginal revenue equals marginal cost. We've got ourselves a marginal revenue curve here. We need to put on here a marginal cost curve. Remember that when we did cost curves, I hadn't talked about types of industries yet. We did diminishing marginal returns, increasing marginal cost, the fact that average total cost hits its minimum when it crosses the marginal cost curve, and all of that we did before we ever introduced the concept of perfect competition, because all of that we did about costs applies regardless of the type of industry. That swoosh shape, Perfect competition, monopoly, monopolistic competition, oligopoly, all the same. The minimizing of ATC where it crosses the marginal cost curve doesn't matter. Perfect competition, monopoly, monopolistic competition, oligopoly, it's all the same. So we're going to put a bunch of stuff measured in dollars on the vertical axis, quantity on the horizontal axis. We're going to have our standard marginal cost curve. So just put yourself a marginal cost curve on your graph. And now let's add in a demand curve and a marginal revenue curve. So draw yourself a downward sloping demand curve and then draw a marginal revenue curve that starts at the same point and splits the distance between the vertical axis and the demand curve. Profit maximizing firm is going to choose to produce the quantity where marginal revenue equals marginal cost. So find the point where your marginal revenue and your marginal cost curves intersect. Drop that down, and we'll call that Q star because it's a profit maximizing quantity, so it's special, so it gets a star. This is a profit maximizing monopolist. Can they charge any darn price they want and sell that quantity? No. How do we figure out what price they're going to charge? Just go up. So Q star is the quantity that's going to maximize profit. The maximum price they can charge if they're a single price monopolist, that is if they're charging everybody the same price, we're going to find by going up till we hit our demand curve and then dash that over, and that's the price P star. Profit maximizing monopolist chooses to produce a quantity where marginal revenue equals marginal cost. They charge a price that is above marginal cost. So here we are away from those Pareto optimal, woohoo, sweet, sweet, sweet conditions. Remember the big bottom line of the first part of the course was in the long run, firms in perfect competition will produce a quantity where price equals marginal cost, not in monopoly. That's where we get our market failure. They're not producing a quantity where price equals marginal cost. They're going to produce a quantity where marginal revenue equals marginal cost because that maximizes profit, but they will charge a price that is above marginal cost. Market failure. Market failure doesn't mean the thing ceases up and nothing happens. It means in this case price is above marginal cost. So they're going to charge a price P star and sell a quantity Q star. If we want to know how much profit is earned by the monopolist, we need to, just like we did before, we need to add in there an average total cost curve. So let's draw some pictures again. Dollars on the vertical, quantity on the horizontal. I change colors just because it's fun to do so, and why have this computer if I'm not going to do things like that? Downward sloping demand curve. Ooh, that was a straight line when I started. Downward sloping marginal revenue curve. It splits the distance between the vertical axis and the demand curve. Standard marginal cost curve. Find my profit maximizing quantity Q star. A single price monopolist will charge a price P star that I find by going up from that quantity Q star until I hit the demand curve. And now let's assume that this monopolist is earning a profit. That makes sense. Why would a monopolist stay in the industry if they were not? Remember that your average total cost curve is going to hit its minimum when it crosses marginal cost. If they're earning a profit, it means you want your marginal cost curve to come down below the demand curve, keeps going down until it hits marginal cost, then comes back up. Call it ATC for average total cost. Or if it floats your boat, call it AC for average cost. Same difference. The firm's producing a quantity Q star. They're charging a price P star. Go up from Q star until you find your average total cost curve. Dash it over. That's the average total cost of producing quantity Q star. And so the profit for this firm is going to be the area of this rectangle between the price and the average total cost. The base of the rectangle is the quantity Q star. The height is the difference between price and average total cost. Same exact process that we did before. The only difference from what we've done before is that no longer do we have a horizontal marginal revenue curve. Now we have one that has a downward slope. That's the only thing that's different so far. If we compare what happens in a monopolized industry with what happens in perfect competition, we get this picture. Dollars on the vertical, quantity on the horizontal, downward sloping demand curve, downward sloping marginal revenue curve that splits the difference, upward sloping marginal cost curve. And for monopolist, the monopolist is going to produce a quantity where MC equals MR. So we'll call that Q sub M. That's the quantity produced by the monopolist. And it's going to charge a price that we read off the demand curve. So we go up from QM until we hit the demand curve, dash it over. PM is the price charged by the monopolist. Suppose that we could take that monopolized industry, kind of like what they did with AT&T. Suppose we could take that monopolized industry and we could bust it up into hundreds of little firms, lots and lots of firms, that were all selling the same product that the monopolist is selling, and you couldn't tell who was selling what, right? It's like zucchini. You get it home, you don't know which booth you bought it from. And there were no barriers to entry or exit into this market. In that case, we would have busted up our monopolist and formed perfect competition. And suppose that when we add up the individual marginal cost curves, of all of the individual sellers in this busted up industry that now has hundreds of sellers in it, suppose when we added up those individual marginal cost curves, which remember are just their individual supply curves, when we added up those individual marginal cost curves, what we wound up with was this marginal cost curve that we already had for the monopolist. So suppose that this becomes a supply curve in perfect competition. So we took the monopolist, we busted it up into hundreds of small little companies, and the sum of the marginal cost curves for all of those hundreds of little companies gives us back a supply curve for the market, which happens to be the marginal cost curve for perfect competition. Well, if this was instead perfect competition, then the price and quantity for the market would be where demand equals supply. In the market, in perfect competition, the price and the quantity are where demand and supply intersect. Find that spot where demand and the supply in perfect competition intersect. Drop it down. That's quantity QC. The fact that on my graph it happens to be where the MR curve crosses the axis is completely random, and it means nothing. Dash that intersection point over, we'll call that PC for price in competition. And we get the standard result, that a monopolist charges a higher price, PM is above PC, and sells a smaller quantity, QM is less than QC. So any given market, if the choice is between monopoly and perfect competition, the monopolist will charge a higher price and sell a lower quantity than would be the case in perfect competition. Clicker question. Oops, my thing went off. There we go. There's only one seller of a Berkeley education, University of California at Berkeley. Go Bears. What can we say about price? A, I have to pay whatever price the seller charges. B, the seller can charge whatever price they want. C, everyone pays the same price. D, not everyone pays the same price. And E, it's kind of weird to think of UCB as a seller. A, B, C, D, or E. I got a bunch of people choosing E at this point. Kind of weird. It is kind of weird. 3 seconds. 1, 2, and 3. Okay. So what do I have here? I've got 32% who gave me answer C and 56% who gave me answer D. So let me ask you a question. Is everybody in this room paying exactly the same price for this semester at Berkeley, yes or no? No. So I don't know why people put down C. UC Berkeley is the only provider of a Berkeley education. There are no close substitutes for it. That junior university down the bay doesn't sell anything that's a close substitute. We know that. Anybody with a tree for a mascot, I mean, please. What we have here in this case, is the ability of the monopolists to do what's called price discrimination. Price discrimination. Now, this is not discrimination in the sense of something that's banned by law, right? This is not discrimination based on categories that are protected by federal or state law. This is discrimination based on willingness to pay. Discrimination based on willingness to pay, which is perfectly legal. I mean, think about the last time you flew on an airplane. Did everybody on that airplane pay the same price? No. People paid different prices for different seats. And probably the person next to you paid a different price for their seat than you paid for your seat, because the seller is able to price discriminate. They're able to charge different prices to different people based on their willingness to pay. So let's draw a picture. Dollars on the vertical, quantity on the horizontal, downward sloping demand curve, downward sloping marginal revenue curve, upward sloping marginal cost curve. It is still the case, even with price discrimination, which means the ability to charge everybody different prices, it's still the case that they will produce the profit maximizing quantity where marginal revenue equals marginal cost. Oops. That is true, but my picture is, wait, scratch that out. Start over. Downward sloping demand, downward sloping marginal revenue, upward sloping marginal cost. Here we go. All right, oops, those things are supposed to be on the same point. Let me use different words because I was going to wind up boxed in. If this is a price discriminating monopolist, it means that they're able to go through and figure out basically who is this person who's willing to pay a really high price? Who is this person that's willing to pay not quite as high a price? Who is this person who's willing to pay a slightly lower price? Who is this person who's willing to pay yet a lower price still? And charge each of those people the price that they're willing to bear. So a monopolist that does perfect price discrimination is able to charge the first person the price they're willing to pay, the second person the price they're willing to pay, the third person, and so on. What it means is that for the single price. For the price discriminating monopolist, the additional revenue, the marginal revenue they get from selling one more unit is not what we have on that marginal revenue curve, which applies for the single price monopolist. For the price discriminating monopolist, the additional revenue is the price that you read right off that demand curve, because they're charging everybody their ability to pay. And so the additional revenue they get from selling one additional unit, there's no price effect. Remember I talked about price and quantity effect? There's no price effect. The additional revenue they get from selling that next unit is the price that that person's willing to pay. And on and on and on, which means that for the price discriminating monopolist, the marginal revenue curve and the demand curve are the same. So I'm going to call this MR for price discriminator. And the price discriminating monopolist will produce the quantity where marginal revenue equals marginal cost, but for the price discriminating monopolist, they're reading that off the demand curve, and so the quantity for the price discriminating monopolist is where demand equals marginal cost. The price, everybody's paying the maximum price they're willing to pay. What's the consumer surplus? How much consumer surplus is there with a perfectly price discriminating monopolist? Zero. The monopolist, if they can figure out what you're willing to pay, they'll suck all the consumer surplus right out of that market and capture all of that consumer surplus. They'll produce a higher quantity. There'll be no consumer surplus because everybody's paying the maximum they're willing to pay. Thank you all. Have a good weekend. Go Bears. I owe you 2 minutes.